All right. Hello, everyone. Thank you for attending my talk. My name is Xavier, and today we'll be talking about Scout Suite, a multi-cloud security auditing tool. By show of hands, can I know who has worked before with AWS, Amazon Web Services, Azure, Microsoft Azure, and Google Cloud Platform, GCP? All right. Those numbers pretty much represent what people usually use. All right. Who has heard of Scout Suite before? All right, more or less. The same people have heard of Scout Suite and people who use GCP, which is pretty good. All right, so Scout Suite is a open source multi-cloud configuration review tool, which basically helps you audit the security posture of cloud environments. What it does is it interacts with the APIs exposed by cloud providers, basically grabs a bunch of information through those APIs, and then presents you with a report that you can then review to see what has been flagged. So, as I said, it uses the provider's APIs, so everything is authenticated. It abides by the, let's say, the policies of each of the cloud providers, so you don't have to advise them that you're running this tool. Currently, we support AWS, Microsoft Azure, and Google Cloud Platform. And a couple of months ago, we released support for Alibaba Cloud, as well as Oracle Cloud Infrastructure. One of the reasons to support these cloud providers, they're not very much used. Well, Alibaba is used a bit more in Asia, was kind of to showcase that Scout's architecture really helped supporting what we call the multi-cloud paradigm pretty elegantly. We'll talk a bit more about this throughout the presentation. The tool, some of you might know of it. It was originally called Scout 2, which was a project that started in 2013, so quite a long time ago when really the cloud was in its infancy in terms of adoption. So Scout 2 was specifically for AWS. So when we moved toward the multi-cloud, we renamed the tool because a bunch of stuff had changed. I would say more than half of the code base changed to support that. The tool is released under GPL v2. It's received a bunch of contributions on GitHub. More than 24 people have contributed. And if you're interested in more details after the talk, on GitHub, the wiki has quite a lot of information. All right, so what's the multi-cloud paradigm? Well, initially, AWS was really the only cool kid on the block. Everyone was using it. But through time, the last 2 to 4 years, I would say, with the rise of Microsoft Azure, with GCP coming out with a bunch more services and functionalities, we've really come to this place where many organizations, especially the large organizations, are no longer relying on a single cloud provider, but are distributing their infrastructure and their platforms on a number of different cloud providers, right? There's really a lot of reasons for this. One of the big ones, as always, is cost. Let's say you have an organization that relies heavily on storage buckets. The whole application is hosted in AWS, but then you realize, well, moving the storage buckets to this other provider is going to cut our costs by 70%, which is quite possible. Considering a lot of the similar services work in a similar fashion, there's not that much of a lock-in into a specific service from a specific cloud provider. Like a storage bucket in AWS works pretty much the same way as in Azure and GCP. So if the functionalities are the same and the cost is lower, a lot of organizations are going to choose the lowest cost, right? Another big one is always familiarity. If it's a side project you're doing for fun, well, often you'll go towards something you already know. A lot of organizations often work with this model. Let's say I have a team and the team has a lot of experience with Azure. Well, it might be worth telling them to build whatever product you're building with Azure instead of spending a month to get to know AWS, right? Another one is offering. Depending on the cloud provider you're using, the services available to you will vary. Obviously, all cloud providers are trying to get to the same point where they're offering the same services. Well, they're trying to offer the best services, but it's pretty much a rat race where everyone is trying to put out the same stuff more or less at the same time. And then the final one is resilience. You really get pretty good resilience by using a single cloud provider, but distributing your resources through, let's say, regions. But obviously, if you're using multiple cloud providers that have completely separate infrastructures, you have a bit more resilience there, right? So at NCC, what we've been seeing in the last 2 or 3 years is that organizations' security posture when it comes to AWS has really been improving greatly. But obviously, as organizations have started also moving away from maybe AWS and also starting deploying resources in Azure and Google Cloud and other cloud providers, well, obviously they have to do the whole process of learning security again and implementing security again. So what we've seen is that by organizations starting to adopt the multi-cloud paradigm, their security posture has taken, let's say, a step back. So hopefully with tools such as Scout, we can help them better secure their environments and help us assess their environments also. All right, so cloud providers' similarities. Once you start looking at a lot of cloud providers, how they're implemented, what are the functionalities that they expose, you start realizing, well, everything is pretty much the same when it comes down to it. The big one, as always, is identity and access management. So any cloud provider is going to allow you to create users, create groups, have some kind of programmatic identity so that your code can authenticate to the cloud provider and access other services. So in AWS, it's roles, you have service principals in Azure, you have service accounts in GCP, and obviously you always have some sort of policies or permissions that allow all of these identities to carry out actions and interact with the different services, right? Cloud providers generally segregate resources through regions. It can be a closer knit relationships or more of a segregation, but that's common for all cloud providers, mostly because the region is kind of an abstraction of where the actual data centers are. You also have virtual private clouds throughout all cloud providers. It's basically a network where you can deploy resources. Nowadays, most resources are networked, so you need a way to configure IPs and firewalls and routing, etc., right? And resources. For all cloud providers, the base unit is a resource. Anything can be a resource, a virtual machine, a user, a network, an IP. Obviously, that allows you a lot of control over your cloud environment. It also allows them to bill you for every specific little thing that you're using and make a lot of money. In terms of services, well, it's pretty much, again, the same for all cloud providers. You have infrastructure as a service, you have platforms as a service, software as a service, function as a service. They all have different names for each of these services, but when it comes down to it, they pretty much do the same thing. So if you have virtual machines in Azure are pretty much the same as virtual machines in AWS. If you have functions as a service, right? So serverless computing, well, in the end, serverless computing is the same pretty much everywhere. When we come down to the risks, again, since you pretty much have the same structure and the same functionalities, the risks are quite similar. Access controls, again, is one of the big ones. So the big one is, first of all, well, whether or how your credentials can be leaked, and then what are the vectors of privilege escalation once someone has compromised your credentials. The second one is publicly accessible resources. Organizations are very much scared of this one. There's been just so many instances where sensitive information has been leaked by storage buckets, database backups being publicly accessible on AWS, etc. There's been so many cases, and some of them have had such significant impacts. For example, the Capital One breach that happened, a couple of weeks ago was kind of an instance of the first two. So it had kind of an access control issue, and then that allowed resources to be publicly accessible, and then hundreds of, I think millions of client records were made public. So these issues can really have very significant impacts on organizations. There's also the case of development practices, right? So when you're using cloud environments, it becomes so easy to deploy resources, and even really very vast resources or very vast environments very quickly, that quite commonly teams, especially when they have more of a DevOps workflow, will have a constant cycles of deploying resources, scratching everything, starting from zero. And one of the issues with that is when you kind of use the the age-old tried-and-true workflow where you start designing stuff, and then the security team comes in, reviews everything, then says, okay, this is fine, we can publicly expose this, and then you do it. Well, it gives you a bit more of an assurance. But when you're constantly changing your whole infrastructure, it becomes much harder to ensure that on a Wednesday morning, someone didn't start creating all of these publicly exposed resources, right? And then, as always, you have the incident response and disaster recovery, which Organizations have become with the years much more capable when it comes to their own on-site infrastructures, but then when you move everything to the cloud, the paradigm changes, the tools and the approaches have to change somewhat. So the readiness of organizations to respond to those situations really has to improve in the next, year or 2 years, decades. I mean, in a decade we'll probably use something else, but anyway. So we've talked a lot about Scout, but what is or how does Scout actually work? So it's really quite simple. It's a Python-based tool. So let's say I want to run it against a AWS account. I could just run Python Scout, and then here I'm giving it a profile. This is basically the same as if you were using the AWS CLI to run a command against. Yes, of course. All right, everyone can see? Yes, right. Great. So it's pretty much the same as if you were running a command against AWS CLI. If you're running it against GCP, it's pretty much the same. So you can use user authentication, or you can use a service account. If you're running it against Microsoft Azure, again, the same. You can run it pretty much all of the authentication strategies provided by the cloud providers are available through Scout. So then you just run the scan. What it'll do is it will first authenticate against the cloud provider, and then it will start fetching the resources for each of these services that are supported. Once it's done grabbing all of that information, it'll kind of do some processing to analyze it, and then what it does is it generates a report, which is basically a static HTML report, which you can view in your browser. So again, this is a multi-cloud tool, and one of the things that we've really strived to do is ensure that whatever the cloud provider you're scanning, we're presenting the information in a similar fashion. So for example, in this case, this is a report for Amazon Web Services, but then we have here a report for Microsoft Azure. We have here another report for Google Cloud Platform. So you can see that the structure is really pretty much the same. And we have another one for Alibaba Cloud, as well as for Oracle Cloud Infrastructure. If we go back to the AWS one, so basically the main dashboard is just a list of all of the services. In this case, we've only scanned the CloudFormation and IAM service. And you can see that we have a certain amount of resources, we have a certain amount of rules that are used, because Scout is a rule-based tool. So you have a bunch of rules, and you can create rule sets if you're only interested in specific types of issues. In this case, if we focus on identity and access management, we can see that we identified 48 resources. So those would be users, groups, roles, managed policies, etc. We have 32 rules written for the IAM service, and out of those 32 rules, we had 11 resources that were flagged, and the total was 233 checks. Anyway, so if we drill into identity and access management, then these are the actual rules. We can see some of them were flagged as really a important finding, whereas some of them are maybe a bit less critical, or should be looked at into more detail to assess the risk rating of that issue. You can see most issues have descriptions. This is one thing we're trying to improve. So for example, in this case, what was flagged was that there was a cross AWS account access that was set up, but that wasn't requiring external ID or for a user to have MFA enabled, right? If we click on defining, what we'll see is the different resources that were affected by this specific issue. If I go on show all, it'll basically show all of the IAM roles within the account, but this specific finding only flagged these two resources. One of the important things about the Scout report is that when, let's say you have an issue in AWS with a resource, quite often you'll have to go through the management console and then go to a bunch of different pages to get all of the information you need to really understand whether or not it's an issue or a false positive, what's the actual impact, as well as the details of this issue. One of the things we do in the Scout report is take that information from all of those different parts and put it all together in a single pane, right? So quite often with cloud providers, an issue can even be cross-service. So you'll have to go to the pages for one service and then understand kind of the bits of information from there, then move back to the other service. In this case, what we do is we really aggregate all of the information in the report in a much more comprehensive fashion. We'll show an example of this I believe for Microsoft Azure a bit later in the demo. If we go to, let's say, the Google Cloud Platform report, it's very much the same. We go into the cloud storage. We see that we have a bunch of, we have 4 issues here that were flagged. Cloud storage is the equivalent of AWS S3, so storage buckets, and it's pretty much the same. We'll see this a bit more in detail, but you can see, well, okay, so we checked 7 storage buckets, and we flagged this specific issue for one of these buckets. As you can see here, we have a reference for the SIS benchmark. One of the things we've been working towards is to support the SIS benchmark for AWS, Azure, as well as GCP, and we're building specific rule sets for these benchmarks. So let's say your organization is specifically interested in ensuring that you comply to the latest AWS SIS benchmark, then you can leverage Scout to see if there are any services that are configured in a way that does not comply to what the benchmark says. One of the issues when you're dealing with cloud environments is that it's not always self-evident whether an issue is an actual issue or a false positive. Let's say you have a storage bucket. The bucket is configured so that all of the files within it are publicly available. Well, maybe that bucket stores static resources for a web application, which have to be publicly available, or they can host all of the information for all of your clients, which is obviously not something you want publicly available. So Scout will flag these independently of what's in the bucket, and then you always need kind of a human that comes in and sees, well, whether or not that's an issue or not. We do support exceptions, so let's say you're running Scout every week against your infrastructure, and you don't want the same static file storage buckets to pop out every week. You can create exceptions and then feed them into Scout so it won't flag specific resources for specific findings. All right. Go back to the presentation. All right, so at this point, at least from my perspective, because I'm quite close to the tool's architecture, I see it almost more as a framework than as a tool. So as you can see here, for the Scout Suite architecture, I won't go too much into details, but we have really the core of the tool, which is for those of you taking pictures, it's fine. All of these are in the wiki. So if you want the specific images or whatever, you can just go on the project's wiki. So we really have the core of the tool, which is the rule engine, the processing engine, something that's really leveraged to whatever cloud provider you are assessing. Then there's the output package that generates that takes care of the whole generation of the report. And then what happens when you go into the implementation of each provider is we really took a hard look at how each provider worked and used kind of our own experience dealing with these and working on Scout 2, etc. And we've come down with like a base, which is like the base package for a cloud provider that details all the different pieces you need in order to create a tool to scan a cloud provider. And then what we did is, using that base class, we implemented support for, in this case, we're just showing these 3 cloud providers, but we implemented it for 5. So let's say we're talking about authentication. Well, authentication is generally the same, right? You have some credentials, you send the credentials to the cloud provider, you get back some kind of token, which you can then use to make authenticated requests. But obviously, the specific implementation of this operation is completely dependent on the cloud provider you'll be scanning. So it's something we've abstracted in the base class, and then something that you can implement in each of the providers, which gives you really a lot of flexibility, because quite often in tools, when you want to write plugins and etc., you might have a situation when you're like, well, this specific instance doesn't work the way it's expected, or the way the tool expects me to implement it. So it becomes kind of an issue. In this case, we really believe that we've found a pretty good base implementation that allows you to support, in this case, cloud providers, but anything that has really an API could, in theory, be supported by Scout. All right. This is just basically the amount of services and rules we currently have. Obviously, there's a lot more that's currently supported for AWS, the reason being that the tool has been supporting AWS for the past 6 years. Azure, GCP have been supported for around a year, maybe a bit less, and Alibaba Cloud and OCI have been supported for 2-3 months. Obviously, also we see that a lot of our clients use AWS over other cloud providers, much more than Alibaba, obviously, or OCI. So yeah, we kind of try to focus our attention on what people are actually using. As I mentioned, there's a bit of advanced features in Scout, which I won't demo right now. So you have findings and rule sets. So as I mentioned, Scout basically has a bunch of findings. Let's say you just want a rule set to scan 10 findings, then you can write your own rule set. We support exceptions to ensure that if you run Scout every week, you don't get the same false positives every time. You can export specific chunks to CSV and JSON. This is quite useful for consultancies where you use the tool's output to write a report. Well, exporting it to CSV or to a Excel file really helps with that process, as well as report parsing. There's a lot of people who use the outputs to feed it into their own issue tracking solutions. We're also working towards allowing to export Scout into cloud-native solutions. Like we'll talk about this in the conclusion. But yeah, so there's a bit of more advanced functionalities, which are again detailed in the wiki for those interested. Obviously, the tool is on GitHub. If you have any issues, there's an email address in the project. You can open issues. We'll answer as fast as our workload allows us to. All right, so here what we'll do is I have 3 scenarios for AWS, Azure, and GCP of pretty typical issues that we find in our day-to-day assessing cloud environments, and how Scout can help you identify, assess these issues, right? So the first one is a privilege escalation vector in CloudFormation. By show of hand, who has used or knows of CloudFormation? All right, so a bit of people. So CloudFormation is a infrastructure as code service. So you write a template in YAML or JSON of the infrastructure you want to deploy. So you can say, I want one network with one virtual machine. That's it. You write the template, you pass it to CloudFormation, and it takes care of deploying these resources. So this is really useful because it allows you to put the templates, let's say, into a GitHub type solution, so you can track the changes. It allows you to revert changes. It's really very useful. One of the issues here with AWS is you can configure the service to use a specific identity, and that allows for privilege escalation to happen. We won't go too much into detail on how that works. It would take a bit more time than I have, but what I will show is how you would typically identify this type of issue, right? So in this case, we have a Scout report for a specific AWS account. As we can see, we only scan the CloudFormation and identity and access management, mainly just to remove clutter that would be found if we scan the whole thing, right? So in this case, we can see that the issue was that, as I mentioned, a role was passed to a CloudFormation stack, which potentially could allow for privilege escalation scenarios to happen, let's say. Right, so what we see here is the stack was configured with a specific role. So let's say we dig into the role. And this is what I was mentioning before of having kind of a cross-service information through the report. So what you're seeing here is information of the identity and access management service, whereas what's in the background is information from the CloudFormation service. So if you were using the AWS console to view this information, you would have to go back and forth. In this case, it's presented in a somewhat more consistent fashion. What we can see here is that the role, what's important here is to see that the role has identity and access management full access, as well as full access to EC2. So it's quite a significant amount of privileges for a role, which means that if someone was able to, let's say, leverage that specific role, they would have basically root access on your account, because if you have full access to the identity and management service, it allows you to change your own privileges, which in turn can provide you with root privileges, right? So then if we go back to the panel and we dig into the IAM service, we can see again the issue I mentioned, which was cross-account assume role policy lacks external ID and MFA. This basically means that someone in another AWS account can impersonate an identity within your own AWS account, and you're not enforcing them to use MFA or an external ID. Obviously, MFA is really a great way of ensuring that even if credentials are compromised, those credentials without the additional MFA won't be usable, right? So what we would see here is, in this case, we only have 2 roles. This one really isn't very important. But if we see this one called external provider, which you can assume to mean that this is an external provider of whatever client you are assessing. And in this case, we can see that this specific external provider is not required to use MFA. And if we look at the permissions the provider has configured, we can see that they have this policy that's called CloudFormation Stack Admin. If we dig into the specifics, what we basically see is that this identity has full access to CloudFormation. So the issue here becomes that you have an external account that can access your own account, and that has permission on the service, which essentially has root privileges on the account. So as you can see, this can very quickly become a quite large issue. Not only, let's say, if there's like a rogue employee in your provider, but also if someone compromises your own provider, they can potentially move laterally into your own account and then compromise your own account. Getting this type of information through the AWS panel itself is really not trivial. I really find that Scout helps in identifying these types of issues greatly. If we move back to the presentation, we'll go into Microsoft Azure, an example for Azure, expose virtual machines. This is also a big one. Obviously, you're constantly spinning up virtual instances in the cloud. One of the things you worry about is that some of these instances are not protected by firewalls so that ports are accessible, RDP, SSH, you name it, right? So if we go back into, this time, the Microsoft Azure report, if we dig into the network service, we can see 3 findings. So what the findings say is that the security groups, which are basically firewall rules for virtual instances, are allowing, in this case, RDP, SQL, and SSH ports to be accessed. If we look here, what we see is, okay, well, so there's only one security group, which could be seen as a firewall rule, that is allowing this type of access, right? In this case, we can see that there's an inbound rule with a low priority that basically allows all traffic to come in. Then you're like, okay, it's not too bad. The security group rule is called troubleshooting security group, which, if it's a troubleshooting resource, is expected to allow for a lot of access, right? So the question then becomes, what are the resources that are actually affected by this security group? So in this case, we can see that there's only one subnet. We can click on the subnet, and then what we can see is we have instances, which are, well, there's only one instance, and the instance is called VM Web Prod. Obviously, if you see a production instance that's being assigned to troubleshooting security groups, that's probably not something you want, right? If we look at all of the security groups, what we see is we actually have 3. We have a web security group, we have a troubleshooting security group, and we have a dev security group. In this case, and this is really quite common, what probably happened is, well, someone launched the production instance and then tried to access it, wasn't able to access it, so they were like, oh, well, this isn't working, so what am I going to do? Well, I'll try to assign the troubleshooting security group and now see if I can access whatever application is deployed on the instance. Okay, now it works. Then, obviously, what do you do when something works? You leave it as is. You don't touch it. You don't try to go back and start debugging. Everything works. All right, we can go to production. Great. Well, obviously, it's not great. And let's say you're running Scout on a daily or weekly basis, and someone makes such a change to your AWS, to your Azure environment, then this is something that will become flagged. So let's say you're not using exceptions and you're just running Scout, and you wake up on a Monday, look at the output of Scout, and you see that you now have a bunch of instances that are being publicly exposed, then that's something that you would be quite grateful to know about, not 6 months later when someone already broke her box, started moving laterally, etc., right? And now the last example for GCP. One of the important things with these examples is that there was an AWS example and there was an Azure example, and this one is a Google Cloud example, but the cloud provider for each of these is pretty much arbitrary. I could have used, for example, this one applies to Azure as much as it applies to AWS, and the other ones and vice versa. In this case, what we're talking about is storage buckets that have weak permissions, let's say, that expose resources in a way that you would not necessarily want to expose them. We've heard a bunch of stories for AWS. I just think it's a question of time before we start hearing just as much of these issues in Azure and GCP, because fundamentally they provide the same opportunity for abuse. In this case, if you look at the figure, it's simply a web application that is using this one is a bit anyway. So it's using basically two storage buckets. One of them is called static content, so you can assume that it holds the static resources for the web application, and the other one is called public content, which you can also assume to be public storage buckets, right? So if we look at the report for GCP, we can see, okay, here in cloud storage, I have something that's being flagged in red. Red usually means something that's not too good, right? What I can see here is, okay, so I have these two rules that were flagged. The first one says that a bucket is accessible by all authenticated users, and the second one is accessible by all users, right? There's a bit of a nuance here, and it's quite funny because all authenticated users is something that was initially implemented by AWS, which was a terrible idea, because what it basically means, all authenticated users means everyone authenticated to the cloud provider. It doesn't mean anyone authenticated into your specific account. It means everyone authenticated throughout the cloud provider. So let's say throughout AWS. Obviously, there's not a lot of situations where you don't want anyone, where you want everyone from the whole cloud provider to access your resources, but not anyone in general, right? In this case, quite funnily, it's something that AWS realized was not a good idea and have now been trying to phase out. So if you go into the web console, it's not available anymore. But since Azure and GCP have kind of based their own implementation on what the cool kid on the block has implemented, well, they've copied the good stuff and they've also copied a couple of mistakes. So all authenticated users is one thing that GCP implemented that they never should have implemented, right? But let's say I look into the buckets that are accessible by everyone. What's being flagged by Scout is basically the static file bucket is available. I do not want to mark this as an exception. So basically what we see here is that there's basically a bucket reader policy for all users, which is fine since it's a static file bucket. Same thing for the public files bucket. It's basically allowing anyone to read the files from the storage bucket. So in this case, this is being flagged by Scout. Obviously, it's a correct finding. This bucket does have this configuration, but in this case, you could consider it to be a false positive, considering what you know of the solution being assessed. If we go back into all authenticated users, what we can now see is that the static files bucket also has all authenticated users are allowed to read as well as write to the bucket. So what this means is anyone authenticated to GCP, not necessarily your own GCP account, will be able to write files into your storage bucket. This might seem like, oh, well, this never happens, but this is something I've seen more than once on real and some very popular and very much used applications. Let's say you compromised or you found out that a web application, let's say, is using as in this case, a static file bucket. Well, what you could do, for example, is take the JavaScript that's being hosted on that bucket, modify it, let's say, to add some crypto mining code, upload it back into the bucket, and then everyone who goes onto the website, downloads those static files, is now mining whatever cryptocurrency in your name. So it's not necessarily as bad as anyone having access to all of your clients' records, right? But it can still have quite an impact on your organization. All right. So that was the example for GCP. Again, I chose one example per cloud provider, but really these examples apply to these three cloud providers as well as pretty much all the others. All right, so one thing we have seen, so we work on Scout Suite, which is an open source tool, and it's on GitHub. Anyone can use it. A bunch of people use it, and we have a lot of our clients who also use it themselves within their own organizations to secure their own cloud environments. One thing they have asked us quite a bit of times is, okay, so I have this tool, but how can I run this tool, let's say every week, every month, and leverage it to ensure that when security issues arise in my cloud environments, which always happens at some point, I'll know about it quickly, right? So what we did is, on top of Scout Suite, we built a software as a service solution, which basically helps people to ensure that they have cloud-based persistent monitoring on their cloud accounts. One of the great benefits of this is that since Scout is a multi-cloud tool, it provides a kind of one-stop shop for persistent monitoring of environments in the cloud, which is really quite useful for organizations that might have a large amount of accounts across different cloud providers, right? So I'll just do a very quick demo. I mean, the goal of the presentation is not to do a product demo. So basically, it's a software as a service. As you can see here, this is the main dashboard where I can see all of the Scout jobs that were run. You can see I ran one just before the presentation. So let's say I come here into my cloud accounts. So you can see these are the cloud accounts that are configured to be scanned. I can go into a specific GCP account. One of the great things is I can schedule jobs. So let's say I want this to run every day in the morning, because I have a DevOps team that is constantly changing resources, and I want to ensure that from one day to the next, we don't go from having no security issues to having a bunch of buckets publicly available with read and write configured, right? So you can also execute scans manually, and you can view the results of the scan. When you view the report, it's pretty much the same thing as when you are accessing a Scout report locally. We do have a bit more of functionalities in the service than in the open source version. It's, how can I say, like the open source version is always a bit behind on what we have in the service, because this is also something we use at NCC internally for our own delivery. But once you know how to use the open source tool, the service pretty much does the same thing. All right, so that's it for Scout. And going forward, well, obviously our goal is to improve support for all of the cloud providers that we currently support. So for example, as I said, for AWS, we support something like 25 services, but AWS itself has something like 170 services. The core is really more around 30 to 35 services, but what we're working on is not only improving the core, but also constantly adding support for new services and implementing new rules. We also want to focus in the next, let's say, year or so on really privilege escalation. This is something that has become more and more of an issue in AWS, and that will obviously become more of an issue also for other cloud providers. And as I mentioned before, we are working towards implementing integration with native security management solutions. So we have a lot of people using the Security Hub. So what they say is, well, I want to be able to directly import a Scout report into AWS Security Hub to then do tracking of all of the issues that are being raised. Same thing for Azure Security Center and GCP Security Command Center. As I said at the beginning of the presentation, all cloud providers strive to be pretty much the same. So obviously, AWS is not the only one that has such a service. Also contributes. So the tool is open source. If it's something that you use, we receive PRs quite regularly. We always accept them, even though sometimes there might be a couple of things to change. If you use heavily Oracle Cloud Infrastructure or Alibaba Cloud or IBM Cloud or whatever in your organization, and you find yourself with the need to have a tool that allows you to assess the security posture of these environments, well, implementing support in Scout Suite is very much a possibility, and there's really a bunch of information in the wiki on how can I add support for a service, how can I add a new rule, how can I add support for a whole new cloud provider. So I really invite you to do this. Special mentions. They're not here, but I just want to thank these specific people who have been really contributing to the tool. So Loic is the original author of the tool. He started back in 2013. We have a great team from the Polytechnic University of Montreal that really did a lot of work on the open source project, really helped a lot, as well as Matt Lewis, research director, I believe, for NCC. All right. Any questions? Yes?
One of the things you scan is AWS KMS.
Mm-hmm.
What sort of things you would flag?
With KMS, it's mostly keys that aren't being rotated, outdated keys. I mean, for AWS and also other cloud providers. Where it also becomes quite useful is, well, so KMS is a service to encrypt resources, right? So it's very much used in conjunction with other services. So let's say you have a database, you have a drive for a virtual machine, etc. You want to know, well, am I actually encrypting my resources, and am I also encrypting it with keys that I control? So it's not only a question of flagging specific issues in KMS, but it's also ensuring that other services are leveraging KMS to encrypt those resources.
So with that in mind, do you also scan, for instance, HSM as well?
Cloud HSM is not currently one of the services that is supported for AWS. The only reason for it is we just haven't put the time in to add support for that specific service. Yeah, it's really been a question of how much time can we dedicate to all of the specific components. But yeah, if when people have like a specific need and they write, let's say they open an issue in GitHub or like, oh, I use this service a lot, why isn't this being supported? We usually try to put it a bit higher up our stack. We're really trying to make it more of a community-driven project. Thank you. Anyone else? Yes. Mm-hmm. Yeah. Mm-hmm. Yeah, so it does do it. So in this case, there's not a new issue, but basically this is a specific scan of the cloud environment. And here what you can see is whether or not there's any new instances of specific issues or new issues that are being raised, as well as whether or not you resolve issues, right? And you can see it here in the web application, but you can also get email notifications. So let's say every time it runs, it'll send you an email and say, well, these are the new issues that arose within your account. Yes?
For Microsoft Azure,
Mm-hmm.
certain stuff like, I think, subscription level like MFA stuff,
Mm-hmm.
you can't get that by the CLI, right? You need to use the Graph API.
Yes, that is correct. So Scout leverages the APIs exposed by the cloud providers. Azure is really the cloud provider that is not putting as much priority into their APIs. So we're kind of always like one step behind them. So we look at their SDK, we realize, oh, they've released a new version. Well, what are the things that they've added now? So, okay, so now we're able to implement support for this. So AD, basically all the users and groups and everything, is something they released support for back in May, and this is something we've started adding into the tool. MFA and a bunch of other things are still not possible to implement. But we're basically just behind them, waiting for them to release stuff so that we can also implement support for it. All right. Well, thank you for attending. If you have any questions, I'm here.